Hello and welcome. In this video tutorial, we will learn about one way to perform a hand-eye calibration with MVTec HALCON. Consider this setup as an example. Using a robot and a stationary 2D camera, we want to pick and place this wooden block from a planar surface. To do this, we have to convert the object coordinates from the camera's perspective into the robot's coordinate system. In this video, we will perform a hand-eye calibration for this setup. We will determine the pose of the robot base and the planar surface relative to the camera and perform a rudimentary camera calibration. In the next video, we will locate the object in the 2D image using shape-based matching. Then, we will determine the robot poses to approach the object. For the tutorials, we adapted these HDevelop examples, which are a good starting point for your own similar application. In this example, we perform the hand-eye calibration by approaching points on the plane. More on this later. The robot only returns the coordinates of its flange. However, we will approach the plane with this center point of the current tool. Thus, we need to determine this offset. To do so, the procedure Calibrate Robot Touching Point is available in HALCON. The idea here is to approach the same point with the touching point of your robot 3 times, rotating the gripper around at least 2 axes. Here you can see the current pose of the robot. Take care when converting your robot's poses into HALCON poses. Consider details like the order of rotation and translation, meters versus millimeters, degrees versus radians, and so on. Additionally, there are multiple ways to communicate with robots. In this case, we use HALCON's generic socket communication. After approaching the same point 3 times, we get a visualization of the 3 robot poses. From these, the procedure determines this offset. Next, let's perform the hand-eye calibration. In the aforementioned HDevelop example, we recommend using a calibration plate for this step. First, we place the calibration plate on the plane we want to pick from. The procedure Calibrate Camera and Plane Single Image then performs a rudimentary camera calibration. Check the root mean square error of the calibration and the pose of the calibration plate relative to the camera. Then we use the finder patterns of the calibration plate to perform the hand-eye calibration. Approach at least 3 different points in the plane with the robot to get the correspondence of the camera coordinates and the robot coordinates. In the graphics window, we click near the finder pattern we just approached. The correct point is determined automatically in the example. For an ideal calibration, the finder patterns you approach should cover the corners of the plane. To optimize this, you may also move the calibration plate. You just have to make sure that at least one finder pattern is visible in the image. Having performed this action 3 times, we get an estimation of the precision. We can either acquire more data or continue with this result. Finally, you can check the results using this visualization of the hand-eye calibration and the approached gripper positions. At the end, the results are written to file. We save the camera parameters, along with the poses of the robot base and the plane relative to the camera. This data can be used for the next step, the Pick and Place application. This concludes this introduction to hand-eye calibration with HALCON. Note that this is only one way to perform a hand-eye calibration. Check out the solution guide on 3D vision, in particular, the chapter Robot Vision, for more methods like using a moving camera or 3D data. Thank you for watching.